Hi everyone, in this class we will be looking at the topic moment of a force. Now in this class we will be looking at the introduction, some formulas, conditions for a system of forces to be at equilibrium, and so many things that we will be learning in this class. Now when we talk about the moment of a force, we are actually talking about the turning effect of a force about a given point, and generally, let me put that here, it's just can be defined, let's say moments of a force can be defined as the turning effect about a given point. So what we're trying to say in mathematically, saying that moment of a force is equal to force times the perpendicular distance from a given point. And having said that, there are some cases that we will be looking at in this class. Let's say case 1. In case 1, we have a situation where the force and the distance are perpendicular to each other. So in this case, we will have the formula moment of a force to be equal to force times distance. Now let's see case 2. In case 2, we will be looking at, let's assume you are given questions where the force is inclined at a particular angle theta to the distance covered. Here we use the formula moment of a force to be equal to Fd sine theta. Fd means force times distance sine theta. So any angle you are giving here, substitute the angle here and you will get the answer. Now case 3. In case 3, let's assume you are given a situation where the force is in line with the distance covered. Here moment is equal to 0. Now, having said that, we will be looking at conditions that necessary for system of forces to be at equilibrium. We'll be looking at this subheading from 2 angles. One of them is talking about parallel coplanar forces, and the second one is when we're looking at non-parallel coplanar forces. Now, having said that, it will be worthy of note to be able to differentiate between coplanar and collinear forces. Now, when you say coplanar forces, you are talking about forces that act on the same plane. And when you say collinear, you're talking about forces acting in the same line. Now, there is nothing to be confused about. I want you to look at this word planar. Planar here, from the word planar, I can bring out the word plane. So that means here I'll be talking about coplanar forces, talking about same plane. Now, when you say collinear, from the word linear, we will be bringing out the word line. So yeah, when you talk about collinear forces, you're talking about forces that are acting on the same line. So having said that, the next thing we will be looking at is what then are the conditions that need to be met, when a body is to be in a state of equilibrium. So here we talk about parallel coplanar forces. Now there are some conditions that need to be met here, and one of them is talking about the sum of upward forces must equal sum of downward forces. Now number 2 condition, that's talking about the second condition. The second condition is when a body, let's put that down, when a body is in a state of equilibrium, the sum of the clockwise moments will equal the sum of anti-clockwise moments. Now let's pause a bit. This second condition is also known as the principle of moments. So that means if you are to apply the principle of moments, the condition is the body must be in a state of equilibrium. If that body is not in a state of equilibrium, then you can't apply this law. Now, having said that, I want us to look at a situation here. In this case, we are looking at a uniform rod. Of course, any uniform object will have its weight acting at the center. So if this is 10 centimeter in length, then the weight of this body will be acting at 0.5 centimeters. So here, let's assume that this is W, and we want to let's assume this rod is pivoted at this point, and we have another weight here. Let's call this W1. Let's have another one here. Let's call this W2. Now in this case, let's assume that the point here is D1, this is D2, this is D3, while this is D4. D here is talking about their positions on the meter rule. So that means W1 is at position D1. So if that is the case, I want to take moment about the pivot. So I have to put that statement here. Taking moment about the pivot. Please note, WAEC will mark you down if you do not put these statements. You will start losing marks. So please, it is very, very important you put this statement there to give examiners the mindset and to be aware of the point at which you are taking moment from. So if that is the case, I want us to look at these three weights and see how they will swing. Of course, the three of them will swing towards the point where we are taking moment from. So in this case, this will swing here, this swings here, this will swing here. So if that is the case, if we are to look at their respective directions, we can confidently say that this is in the clockwise direction, anti-clockwise direction. And if that is the case, I want us to now apply this second law. That is, when a body is in a state of equilibrium, the sum of clockwise moment equals the sum of what? Anti-clockwise moment. So taking this, looking at this, you will see that our clockwise moment here will be equal to, let's see, that will be W multiplied by, we need to find the difference between these 2 points, and that will be, of course, if you are to say this is 0 and let's say this is 100, since this is a meter rule, we are assuming is a meter rule, you expect this distance to be greater than this, and d4 should be greater than the remaining points. So in that case, let's see for the first one, which is W here, talking about the clockwise moment, its point is D3, and the point here will be what? The point of reference here is D2. So everything will be deducted from D2. So let's see, W will be D3 minus D2. Now, do we still have any other clockwise moment? Yes. So we keep adding. So here I can say plus W2 will be what? D4 minus what? D2. So having said that, we'll go straight to what? The clockwise moment. So your clockwise moment here is going to be, anti-clockwise moment will be W1, and what's its point? So here you're not going to say D1 minus D2, because of course D2 is greater than D1. So here it's going to be D2 minus D1. Now I want you to look at this very well. You see that the D2 is common to all our values here. Is common. So that's to tell you that that is the point we are taking moment from. But if peradventure, let's assume you are giving something like this. Look at this. Let's assume you are giving something like this, and you were told this is moment, of course. Let's say here we have our W, here we have our W2, here we have our W1, and here you are giving distance. There are distances. Let's say here you're giving D1, here you are giving D2, and here you are giving D3. So in this case, this is different from this, because here you are giving the distance from the pivot, but here you are only giving their position. So if you are giving the distance, you can go ahead and use the distance straight away. So how do I mean? We are still taking moment about the pivot. So here you have your anti-clockwise moment. Clockwise, yes, you talk about the clockwise here, and here is also in the clockwise direction. So in this case, I'm going to be having, good. So let's say we are taking the same condition. Yeah, we say same. So in this case, it's going to be, let's take our clockwise moment. What will be our clockwise moment? Our clockwise moment is going to be W times the distance from the pivot is D2. So here you just say times D2. So then we still have another clockwise moment, that will be W2. W2, its distance from the point we are taking moment from is the sum of these two distances. So here you are going to say D2 plus what? D3. Now when you're through, you go by the what? Anti-clockwise moment. Now in your anti-clockwise moment is going to be W1 times the distance from the pivot is D1, and of course applying the principle of moments. what will this be? It will be WD2 plus W2 D2 plus D3 will be equals to W1 D1. Now, if we are to apply the same thing here, let's put it there, applying the principle of moment, then you will get W D3 minus D2 plus W2 D4 minus D2, which will be equals to W1 D2 minus D1. And of course, the same thing, you will see that D2 is common. So that is the concept here. So if that is the case, all you have to do is substitute the values you have and solve for any one of them. Any one of these can be unknown. In moment, it can be the weight, it can be the distance, it can be the position. So any one you are given, just make sure you go through and you will get it. Now, having said that, we want to go straight to case 2. In case 2, we want to look at the non-parallel coplanar forces. This one also has its own conditions. Now, we want to look at a situation like this. Let's say like this. Let's say like this. So here you talk about F1, and here you talk about F2, and here you talk about what? F3. So in this case, we have the following conditions. The first one will be the algebraic sum of the horizontal components of the force, or of the forces rather, must be 0. How do we mean? Let's assume you resolved along the horizontal axis. If you add all the horizontal components of the force acting on a body, it must be equals to 0. Now, number 2, the algebraic, yes, it's still the same. So here we talk about the algebraic of the what? The algebraic sum of the, now instead of horizontal we say vertical components of what? Of the forces must be 0. So here we talk about the algebraic sum of what? F of y, that will give 0. Now another one is number 3, and that is talking about the principle of moment as it were, which happens to be if a body is in the state of equilibrium, just as I've stated it earlier on. The algebraic sum of the word clockwise moment is equals to the what? The algebraic sum of the what? Anti-clockwise moment. And here you talk about equilibrant. Like if I have these 3 forces here, I can F1 here can represent the equilibrant force that balances the effect of these 2 forces. Let me share one question with you here. Yes, I have it here. Now let's see. 3 non-parallel coplanar forces, which can be represented both in magnitude and direction by the 3 sides of a triangle taken in order, will have any one force being the equilibrant of the other 2. This is correct. Make a body move randomly. No. Make a body oscillate? No. Move a body along a straight line? No. Rotate a body about its axis? No, because the body is in the state of equilibrium, so therefore that body would not rotate. So the correct option here is option A. So that is that. All right, so here we have a question here. This is one of the past questions. And this, let's see, 1 meter long uniform rod. Please, whenever you hear the word uniform rod or uniform object means that the weight of that object will be at the center. Very, very important. The weight of that object will be at the center. So in this case, is balanced horizontally under the action of forces 2 Newton and 1 Newton as illustrated in the diagram below. So we have the diagram, and the question is the weight of the rod is, this will automatically be at the middle. So for the fact that we are told to calculate the weight of the rod, all we need is what is the total length of this rod. It is 1 meters. So if I convert this to centimeters, it's going to be, this weight will be at where? 50. So quickly, let's see how that works. So I'm going to be having, let me do it this way. This is the shape. So we have our force here, which is 2 Newton. We have the pivot here, and we're told the distance here is 30 cm to the what? To the pivot. And here we have the weight of the rod, which is W. And for the fact that this rod is 1 meters, that means if you convert that to centimeters, it's going to give you what? 100 cm. So if you have 100 cm, that means the weight of that object will be at the center of the rod, which will be at where? 50, being the half of what? 100. So if that is the case, you agree with me that from here to here will be 20 cm. Yes. So if that is the case, the next thing we need to do here is we're told that there is an upward force here, which is 1 Newton. And if that is the case, of course, this will be what? This will be 100 cm, while this end will be what? 0. So if that is the case, the distance from here to here will be 50. How do I mean? 100 minus 50. So that means here will be 50 cm. So if that is the case, I think we are good to go. So now let's see, taking moment about the point, or about the pivot here. So about the pivot. So what would that be? That means this value, this force here will swing towards the pivot. This will swing towards the pivot. This will also swing towards the pivot. So if that is the case, moment here will be, let's see, this is the direction anti-clockwise. This is direction of clockwise. Why this is also what? This is anti-clockwise. So if that is the case, can we calculate the clockwise moment? Okay, let's calculate clockwise moments. So in that case, we are going to be having W times the distance of W from where the pivot is 20. So that will be all for this. So this will just be what? 20W. And what will be the unit? The unit of moment is Newton meters. So now let's see. We'll now go ahead and calculate what? The anti-clockwise moment. So what will that be? That is going to be, see, this is going to be 2 times the distance to the pivot is 30, or from the pivot is 30. Then we have another anti-clockwise, so we keep adding. So what will this be? This is going to be 1 times here. So what is the distance from this to this is what? 50 plus 20. So we have 50 plus 20. So if you do that very well, you are going to be having this, which will be, this is 60 plus, if you add these two, you have 70. And if you add them up, you have 130 Newton meters. So if that is the case, applying the principle of moment, and that is equating clockwise and anti-clockwise moment. So this is going to be 20W equal to 130, and what will be your W? Your W will be 130 divided by 20, and that will give you 6.5 Newton. And let's check. Yes, that will be option D, 6.5 Newton. And that is that for this question. Now, let's see another question. This is an IGCSE question. So for those of our boys offering, some of our boys offering this exam, you see, though it's a bit technical here. So let's see how it works. Two forces P and Q act on a meter rule as shown. The meter rule is pivoted at one end, and the rule starts to rotate. Please underline that word, rotate. So don't forget that if you are applying the principle of moment in solving questions like this, the body must be at equilibrium. But in this case, this body is now rotating clockwisely. So if that is the case, what then could have made this body to rotate clockwisely? It simply means that the clockwise moment is greater than the what? The anti-clockwise moment. That's what it means. So here you have P equals Q. No. P is less than Q. No. A and B are wrong. So let's see. This is a moment, isn't it? Yes, this is a force. So yeah, the moment here is P times A. Let's check. P times 8, if we are taking moment about the pivot, is correct, is equal to Q times B. For the fact that is equal, that means this is not correct, because if it is actually equal, it won't be what? Rotating. Are you getting it? So if it is actually equal, it will be rotating. Then let's see, P times A is greater. What's P times A? You say that P times A is the what? Clockwise moment, isn't it? Yes, that's a clockwise moment. And I've said it that for this body to what? To rotate in a clockwise direction, that means the clockwise moment is greater than the what? The anti-clockwise moment. And that is exactly what you are having here. You agree with me that the anti-clockwise moment here will be what? Q times A plus B. Yes, and that is what you have in option D, A plus B, and that option D is the correct answer. Now let's see, we have another question here. In this question, we're told that Mn is a light uniform meter rule pivoted at O, the 80 cm mark. A load of mass 3 kg is suspended on the rule at L, which is the 10 cm mark. So the question here is calculate the tension in the string. So whenever you are given a question like this, the first thing to do is to resolve this tension, because there's going to be a tension in this rope, T. So you are resolving it vertically. So if that is the case, so let's see how to replicate that here. We have this. So here I'm resolving vertically. If I'm resolving vertically, it's going to be what? T sine 30 degrees. And the point here is what? Is 20. We have our pivot at 80. We have our mass at where? At 10. 3 kg at 10. And of course, since this is tension, it will be good for you to what? Convert this to what? To weight, which is 30 Newton. So let's see any other information for us to solve this. I think that will be all for now. So let's solve. So the first thing here is, let's see, taking moment about the pivot. So, and if that is the case, let's see what will be our clockwise moment. Clockwise moment is going to be, check, if you are taking moment about this point, this will swing towards that point, and this is anti-clockwise direction, while this will swing towards that point. This is clockwise direction. So if that is the case, your clockwise moment is going to be, let's check it out. Clockwise moment is going to be T sine 30. Now we are going to find the difference between these 2 points, and that is 80 minus 20. So that if you do that, that will give you the distance between them. So now let's do that. So we have T sine 30 times what? 80 minus 20. So that's what I do whenever I'm giving points. So what will this be? This is going to be 60. The sine 30 is what? Half of 60 is what? 30. So you have 30t. So can we calculate for the anti-clockwise moment? Our anti-clockwise moment will be 30 Newton to be multiplied by the difference between the point where you are taking moment from, and that is 80 minus 10. So here we have 30 times 80 minus 10. So what will this be? That is going to be 70. So if you do that very well, that should give you 2,100. The unit here will be Newton meters. The unit here will also be Newton meters. So tell me, what will this be? If you equate them, that means you are applying what? Applying the principle of moment. So what will that be? That is going to be 30t equal to what? 2,100. So what will be your t? 2,100 divided by what? By 30. So that gives what? 70. So you have 70 Newton, and that is our answer. Here we have another set of questions, but here let's start from question 1. A uniform beam, since it's uniform, don't forget the width will be at the center, and it's of what? 40 meters long. That means the weight will be at where? 2 meters. Now we're told the weight is 350 and it rests on 2 pivots, which kept it in equilibrium by weight of what? 60. This is 80 Newton attached at X and 1000 Newton attached at a point between P and Q, such that it is 0.6 meters from Q. So that means the weight 1000 Newton is 0.6 meters from Q. If XP, don't forget that the length of the beam is XY. That means 0 will be at where? At X. Then 4 will be at what? At Y. So now I want to quickly replicate that here. So let's see. If you're drawing, you have something like this here. Here I have, this is X and this is what? Y. The total length is what? 4 meters. The total length is 4 meters. So if that is the case, here you have the first pivot. The first pivot is what? P, while the second pivot is at point what? Q. And so we have this. So the first thing now is by weight of 80 Newton attached at X. So I'll come to X. I have a weight of what? 80 Newtons here attached at X, which is 0, while this is what? 4 meters. So because the total length is what? 4 meters. So let's see, we have 80 Newton here at X. So let's keep reading. At X, and 1000 Newton attached at a point between P and Q, such that it is 0.6 meters from Q. Now let's see, if XP is what? 0.8 meters. So let's do that here. XP, the first pivot is what? Is at P, and we're told that if XP is what? If XP is 0.8, so we have 0.8 here. Everything will be in meters. So then the second question is, and PQ is what? 2.2 meters. PQ is 2.2 meters. So check the diagram very well. We have P. So we're told that the distance between P and Q, I want to believe that should be somewhere here. Yes, put it somewhere here. So we have Q here, and we're told that the distance is what? 2.2 meters. So if the distance between them is 2.2 meters, that means this point is going to be what? 3. How do I get 3? It's going to be 2.2 plus what? 0.8. You get 3 here. So that's 3. So then the next thing is, where we're told that 1000 Newton attached at a point between P and Q. So it's going to be between this P and Q, which happens to be 0.6 meters from Q. So check this. If this is Q, we're told that a mass here, a weight of what? 1000 Newton is 0.6 away from Q. So if you are subtracting 0.6 from this, you are going to have 2.4 here. That means it's going to be, that means the distance between here, this is what? 0.6. But I personally, I love to use the point so that this makes calculation very, very easy. Trust me, it makes calculation very, very easy. So if that is the case, yes, we're told the weight of the rod is 350 Newton. So, and since it's the weight of the rod, where will it be? At the center, at the midpoint. And it is 350 Newton. So if it is 350 Newton, the next thing now is here is going to be 2. And if you can see, it makes sense. So if that is the case, how then do we now solve? So let's see. Quickly, we are free to take moment at about any point. So yeah, I will be saying, let's see, taking moment about the pivot at P. So if that is the case, of course, here you are going, because if you check the question very well, let's see, the question is we have to calculate the reactions at P and Q. So here you're going to have a reaction at this point, P, and you're also going to have a reaction at this point, Q. So let's say the reaction at P is RP, and let's say the reaction at Q is RQ. So if that is the case, if I'm taking moment about the pivot at P, that means the reaction at P will be 0. That's what it means. So any point where you are taking moment from, always have that at the back of your mind, that the reaction at that point will be 0. So the first thing here is taking moment here will enable us to know the direction. If I'm taking moment here, this will swing towards P, isn't it? This will swing towards P. This will also swing towards P. Some will ask, why are they not swinging towards Q? Yes, they can. That is if we are what? If we are taking moment about point Q. But here we are taking moment about point P. So they will all swing towards that point. So if that is the case, we can now say this is anti-clockwise direction. This will be clockwise direction. This will be clockwise direction. So we have 2 clockwise directions and 1 anti-clockwise direction. So if that is the case, we go clockwise. Let's see, our clockwise moment will be equal to what? C is going to be 350 times, look at the point, this is where you are taking moment from, so it's going to be 2 minus 0.8. Then the other one, clockwise, you have 1000 will be, what's the point of 1000? It's 2.4. Where you are taking moment from is what? Is 0.8. So you have 2.4 minus 0.8. So if that is the case, you do the needful here, 350 times what? This should give you 1.2 plus 1000 times, take the difference here, that will give you 1.6. Yes, that will give you 1.6. So you may want to multiply 350, multiply your 1.2, that should give you 420, and this will give you 1600. So if that is the case, you want to add, if you add this, you will get 2020. Yes, that will be 2020, and the unit will be in Newton meters. So yeah, after that we'll go for the what? Anti-clockwise moment. So which is the same force times the perpendicular distance. So this is the anti-clockwise moment. So here is going to be 80 to multiply it by the difference between the point where we are taking moment from, which is 0.8 minus 0, and that is 0.8. So here I will come here and put 80 multiplied by 0.8 minus 0. So if you do this, you should get 64. And if you get 64, the next thing you need to do here, oh, I've forgotten my RQ. Can we take, where will be the direction of RQ? Yes, towards the point. So we have this. And what will this direction be? This is what? Anti-clockwise moment. So it also follows what we are doing here, definitely. So we'll go to our plus, then the anti-clockwise moment here will be what? The reaction is RQ, and the distance is 3 from 0.8. So we have RQ bracket 3 minus 0.8. So tell me, what will this be? 0.3 minus this should give me 2.2 RQ. So what then do we now do? It's simple. We just have to what? Applying the principle of moment. So if you do that, your anti-clockwise moment will be equals to this sum of the what? Clockwise moment. So you have 2.2 RQ, and you want to do the needful, so it's going to be RQ equal to 2020 minus 64, then divide the answer by 2.2. If you do that very well, you will get 889.1 Newton, and that will be the value of the reaction at P. Now, talking about the reaction at P now, we have found the reaction at Q. So talking about the reaction at P, to get the reaction at P, what we are going to do here is we are going to apply the second condition for parallel forces to be at equilibrium. So what would that be? So you have sum, here we have using sum of, using sum, that will be SUM, sum of what? Upward forces will be equals to what? Sum of downward forces. So what do we have there? Let's check. Go to the diagram. Our upward forces will be RP plus RQ. So you have that here. That will be RP plus RQ equal to this downward forces, 8 plus 350 plus 1000. So let's have that here. 80 plus 350 plus 1000. So you want to do the needful here. You already know what your RQ is. So you have RP plus 889.1 equal to, add everything here, you will get 1430. So RP will be 1430 minus 889.1, and if you do that very well, you will get 540.9 Newton. That will be the reaction at P. And that's not all. Check it very well. The next question now is now saying, if the 1000 Newton weight is replaced with a 1200 Newton weight, at what point from Q should it be placed in order to maintain the equilibrium? So we are good to go. We can still apply the principle of what? Moment here to sort things out. So now let's see. In this case, we're told the same diagram. Of course, we are only changing the same diagram. We're only replacing 1000 with what? 1200 Newton. So here will remain 80 Newton. Here we're told, what if it is now 1200 Newton? Of course, the weight was somewhere here, and the weight was 350. So here we know it was 2. Here we know it was 0.8. And of course, here we do not know. So the question is, if it is replaced by what? 1200, at what point from Q? So mind you, this is where Q is. This is where Q is. So at what point from Q will it be placed? So what I'm going to do here is I'm going to represent this point. Let me represent this point with Y. So if I'm doing that, don't forget that this one is what? This one is 3. Going by our former diagram. Check it out. You see this was 3. We know this before when it was 1000, but when it is now 1002, you can't say it's going to be at 2.4. In physics, we must calculate that, and if you do it very well, you will get the answer. So yeah, this is what we will have. We still have our reaction RP, and we still have our reaction here, which is RQ. So here we are going to do the same thing we have been doing, which is, let's do it, taking moment about point P. So of course RP will be 0. That's a reaction at P. So if you are doing that, this is what happens. I'm going to have this swing. This will swing this way. This swings this way. While this will go this way. So tell me, what will this be? The distance, of course, this is 0, and we have this. So we want to calculate Y. So if I'm taking moment at this point, let's see my clockwise moment first. My clockwise moment, mind you, this will be anti-clockwise. So my clockwise moment now will be what? This is clockwise and this is anti-clockwise. This is clockwise. This is also clockwise. So my clockwise will be 350 times the difference between this, which is 2 minus 0.8 plus 1,200. Here is going to be y minus 0.8, y minus 0.8. And yes, that will be all for that. So here you have 350 times 1.2 plus 1,200 y minus 0.8. And you want to multiply that. If you do this, if you can remember, we actually did it the first time and we got 420. Yes, I think so. That should mean 420. And this, you have 1,200y minus this multiplies this. That should give you 960, if I'm not mistaken. You are free to always use your calculator to verify that, but I think you should give me something like this here. So you want to find the difference. Okay, let's see. You have 540, yes, 540 here plus 1,200y. So that will be that for what? The clockwise moment. Now we now go to what? The anti-clockwise moment. So what will be my anti-clockwise moment? Anti-clockwise moment is going to be, go to the diagram, you have your RQ. Yes, RQ now will multiply what? 3 minus 0.8. So let's give that. So that will be what? Times 3 minus 0.8. So plus, we have another anti-clockwise moment, which is 80. 80 now will multiply 0.8. So you have it here, 80 times 0.8. Of course, 0.8 minus 0 is 0.8. So now let's finish that. What will this be? You already know your RQ. Your RQ is, if you check, it's 889.1. Then you multiply by what? 2.2. Then plus this gives you 64. And you want to multiply that. If you do that very well, you will see that your answer will give you 1956.02 plus 64. And you want to add that, you're free to do that. So if you add that very well, add it very well, you should have something like, let's see. Okay, yeah, you should have 20.02 here. Yes. So the Newton meters here and Newton meters here. So if that is the case, I'm already assuming that the reaction is measured in Newton anyway. So we have applying the principle of moment. So if that is the case, that means you equate this, which is 540 plus 1,200y to 2020.02. So that will be 2020.02 minus 540. Then what will be your y? That will be 2020.02 minus 540, all divided by 1,200. And all you have to do there is just to do a simple calculation. Yeah, a simple calculation. Am I missing something? Okay, yes. Here should be minus. If you check minus 960 here, it should give you minus. And of course, this will be minus. And if you take that here, you will get plus, and plus will be here. So you want to divide this by 1,200. Your answer will be 2.1 meters. 2.1 meters. So now let's see. Look at this diagram. If this is 2.1 meters, so the question is, what distance from Q will you place this? So that means you have to find the distance, the difference between 3 and 2.1. So here I'll come and say the distance of the 1,200 from point Q will be it will be 3 minus 2.1. And if you do that very well, you should get 0.9. Yeah, you should get 0.9. And 0.9 will be the answer. 0.9 meters will be our answer for this question. Thank you.